Somewhere in the cold, gray expanse of the East China Sea, a warship moves through the water unlike anything naval engineers have ever classified before. There are no fighter pilots pulling G-forces in pressurized cockpits. There are no human hands gripping throttles as jet engines roar to life. No crew of aviators strapping themselves in, running checklists, bracing for the catapult blast. Instead, what this ship carries is something far more unsettling to military planners sitting in offices in Washington, D.C., Tokyo, and Taipei. Swarms, autonomous, stealth-capable combat drones, launched at extraordinary speed from an electromagnetic catapult system embedded directly into the deck of a warship that doesn't fit neatly into any category naval engineers ever designed. This vessel is the Sichuan, hull number 51. China's first Type 076 amphibious assault ship, and I want to make something very clear from the beginning. This may be the single most strategically disruptive warship launched anywhere on the planet in the last 20 years. I'm Nico, and welcome to Frontline Reports. Today we are telling the complete story of China's catapult-equipped drone carrier. What it is, how it was engineered and built, why it matters so profoundly, and why senior strategists inside the United States Pentagon are watching its every movement with an intensity that hasn't been seen in decades. But to truly understand why the Sichuan represents such a seismic shift in global naval power, we first need to go back to where China's naval story really begins, and how a nation that once couldn't build a single aircraft carrier quietly transformed itself into the world's most prolific warship producer. For the better part of the 20th century, aircraft carriers were the ultimate measure of a nation's naval ambition and capability. They were the floating fortresses that declared, without words, that a country had arrived on the world stage as a genuine military power. The United States built them with industrial confidence after World War II. Britain refined the foundational technologies that made them viable. France and Russia operated their own versions with varying degrees of success. And China, for decades, could only observe from the sidelines. That began to change in the early 2000s. China's first step into carrier aviation was, by any objective measure, more symbolic than strategic. Beijing purchased a rusting, incomplete Soviet-era carrier hull from Ukraine, a vessel called the Varyag, and spent years transforming it into something functional. The result was the Liaoning, commissioned in 2012. It was as much a statement of national ambition as it was a weapons platform. It told the world that China was serious, that it was committed, and that it was willing to invest the time and resources necessary to master the complex art of carrier aviation. Then came the Shandong in 2019, China's first entirely domestically designed and constructed aircraft carrier, a milestone that demonstrated Beijing had moved beyond simply refurbishing foreign hardware. China was now building from scratch. And then, in 2022, something genuinely significant happened. The Fujian was launched, China's third aircraft carrier, and the first in the country's fleet to feature electromagnetic catapults for launching aircraft. To appreciate what that means, you need to understand the engineering challenge involved. Electromagnetic catapult systems, known in naval terminology as EMALS, electromagnetic aircraft launch systems, represent the cutting edge of carrier aviation technology. They replace the older steam-powered catapults that have been used on carriers for decades, offering far more precise control over launch power, significantly reduced mechanical stress on aircraft, and the ability to launch a much wider variety of aircraft types. The Fujian stretches approximately 316 meters in length and displaces an estimated 80,000 tons at full combat load. It carries 3 electromagnetic catapults, which means it can operate heavier, more capable aircraft that older ski-jump ramp systems simply cannot support, including sophisticated airborne early warning aircraft like the Xi'an KJ-600, which dramatically extends the fleet's ability to detect and track threats at long range. When the Fujian was revealed to the world, it was genuinely stunning. Analysts who had watched China's naval development for years acknowledged that Beijing had leapfrogged several generations of carrier technology in a remarkably compressed time frame. But even as the international defense community was still processing the significance of the Fujian, something else was already taking shape, quietly, behind the walls of the Hudong Zhonghua shipyard in Shanghai. Something that would prove, in some ways, even more consequential than a third aircraft carrier. On December 29, 2024, the Type 076 amphibious assault ship, named the Sichuan, was formally launched at the Hudong Zhonghua shipyard in Shanghai. Military historians and naval analysts will likely mark that date as a genuine turning point in Chinese naval history. Not because a new ship was launched — China has been launching new ships at a breathtaking pace — but because of what this particular ship represents. The Sichuan is not simply an aircraft carrier, and it is not simply an amphibious assault ship. It exists in a category entirely of its own creation. For the first time in recorded naval history, a warship designed to carry troops into combat, deploy armored landing craft to hostile beaches, and operate helicopters across complex amphibious operations. That same ship can also launch and recover fixed-wing aircraft, including autonomous combat drones, using the same electromagnetic catapult technology that until very recently was the exclusive domain of the world's most advanced aircraft carriers. Let that sit for a moment. Before the Sichuan, only 2 warships on the entire planet were equipped with electromagnetic catapult systems: the USS Gerald R. Ford, the United States Navy's most advanced and expensive surface warship, and China's own Fujian. Now there is a third ship in that exclusive club, and it is also Chinese. What exactly does the Sichuan look like up close? China's Ministry of National Defense has described the vessel as having a full load displacement exceeding 40,000 tons, though some independent analysts estimate the figure is closer to 50,000 tons. It features a dual-island superstructure, a distinctive twin-tower arrangement on the flight deck, along with a full-length aviation deck stretching from bow to stern. The dual-island design is itself significant. On a conventional aircraft carrier, a single island houses both navigation and air traffic control functions. By splitting these roles across 2 separate structures, China's naval architects have freed up additional deck space and reduced the risk of a single catastrophic hit, disabling both functions simultaneously. It's a design philosophy that prioritizes operational resilience. The ship's propulsion system is equally sophisticated. Despite displacing over 40,000 tons of water, the Sichuan is driven by a hybrid propulsion arrangement that combines gas turbine engines with electric power systems. A configuration that provides both the high-speed sprint capability needed for rapid repositioning and the fuel efficiency required for extended operational deployments far from home ports. The flight deck itself has been engineered for maximum flexibility. Aviation hangars are positioned to accommodate both helicopters and unmanned platforms. Aircraft elevators on the port and starboard sides of the ship move aircraft between the hangar deck and the flight deck. The layout is designed so that helicopter operations can continue simultaneously at the aft end of the ship, while fixed-wing drone launch and recovery operations proceed forward. This isn't a single-mission platform. It is a multi-mission system designed to operate across a spectrum of tasks simultaneously. The armament goes beyond just the aviation component. The stern section incorporates a well dock, the flooded internal bay used to deploy and recover amphibious landing craft. This means the Sichuan retains its full amphibious assault capability even while conducting drone flight operations above deck. The ship is, in military terminology, a true multi-domain platform. But the element that makes the Sichuan genuinely unlike anything that preceded it, the component that has sent alarm signals rippling through defense ministries from Tokyo to Washington, is its drone air wing. Chinese military officials and PLA Navy commentators have been unusually direct in describing what the Sichuan is designed to carry. This ship will serve as a drone carrier. Equipped with electromagnetic catapults, it will launch and recover a variety of unmanned platforms, including armed combat drones and long-range reconnaissance systems. The drone most closely associated with the Sichuan's air wing is the GJ-11 Sharpsword. This is a stealth, unmanned combat aerial vehicle built around a flying wing configuration, meaning it has no conventional tail structure, which dramatically reduces its radar cross-section and makes it far harder to detect and engage. The GJ-11 is designed specifically to penetrate sophisticated enemy air defense networks and strike hardened, high-value targets. Think of it conceptually as China's equivalent of the American B-2 Spirit stealth bomber, but unmanned, carrier-launched, and engineered to operate not as a solo platform, but in coordinated swarms of multiple aircraft. There is also the GJ-21, a newer combat drone that has reportedly been developed with one specific application in mind: operations from Catapult-equipped ships like the Type 076 Sichuan and the Fujian carrier. The weapons these drones can carry are not speculative or theoretical. Chinese fixed-wing military drones from the KS Rainbow series have already demonstrated integration with the AR-1 air-to-ground missile and the FT-9 precision-guided bomb. These are real weapons with real combat capability, already proven in operational contexts. The integration pathway from drone to weapon system is not a future engineering problem. It is a challenge that has already been substantially solved. PLA-affiliated military commentators have gone even further in their public statements, asserting that once China's air superiority drones reach full operational readiness, the Type 076 will be capable of performing every mission task that a conventional aircraft carrier performs, including achieving and maintaining air superiority over a contested operational area. That is an extraordinary claim. Not because it is implausible. The trajectory of autonomous aviation technology suggests it may well be achievable, but because of what it means for the broader strategic landscape. If a ship that began its design life as an amphibious assault vessel can evolve into a platform capable of contesting air superiority, then the entire framework through which naval power has been understood, organized, and planned for over the last century needs to be reconsidered from first principles. China is not building a bigger version of what already exists. It is building toward an entirely different future, one in which unmanned systems, operating in coordinated swarms, gradually displace manned aircraft as the dominant expression of air power at sea. Before we examine what the Sichuan means strategically for the Indo-Pacific region, it is worth pausing to discuss something that has received less attention than it deserves: the extraordinary speed at which this ship was constructed. Because that speed is not just an engineering achievement, it is itself a form of strategic communication. The first steel sections of the Sichuan's hull were assembled in October 2023. The ship was launched on December 27, 2024. Within roughly 14 months of initial block assembly, the vessel had progressed to a complex first sea period in the East China Sea, conducting stability assessments, propulsion system trials, and navigation equipment evaluations in open water. 14 months, from the first welded steel plates to an operational sea trial in the East China Sea. For context, consider the United States Navy's experience with its most advanced warships. The Gerald R. Ford class carrier, the pinnacle of American naval engineering, typically requires 5 to 7 years from the laying of the keel to commission service. The USS Gerald R. Ford itself took nearly 11 years from initial contract award to commissioning in 2017. The timing of the Sichuan's launch carried an additional layer of strategic messaging. The vessel was launched less than 2 weeks after the Fujian carrier conducted its own major commissioning milestones, meaning China simultaneously advanced both a conventional electromagnetic catapult carrier and a drone-capable amphibious assault ship on nearly parallel timelines. This was not coincidence. This was deliberate choreography, a demonstration to the world, and specifically to military planners in Washington, that China's shipbuilding industrial base has reached a level of scale and efficiency capable of outpacing any rival nation. The numbers that underpin this assessment are stark. According to the U.S.-China Military Power Report, the People's Liberation Army Navy already operates more than 370 battle force warships and is assessed to be on track to reach approximately 395 ships by 2025 and 435 by 2030. The growth is concentrated precisely where it matters most: large surface combatants and aviation-capable platforms. The United States Navy, by comparison, operates approximately 290 deployable battle force ships. A gap that analysts once described as manageable has become something qualitatively different. The arithmetic of naval power in the Pacific has shifted, and it continues to shift. Every month, with every keel laid, with every hull launched in Chinese shipyards from Shanghai to Dalian. The Sichuan is extraordinary. But in the same period that the Sichuan was undergoing its sea trials and fitting out, Chinese engineers conducted an experiment that, when it became known, generated genuine alarm across multiple defense establishments simultaneously. In late December 2025, satellite imagery from the Hudong Zhonghua shipyard in Shanghai began circulating among military analysts and defense journalists. What those images revealed was, by almost any measure, startling. A medium-sized cargo vessel, an ordinary commercial ship, had been observed with a modular, road-mobile electromagnetic aircraft launch system installed along its deck. The same ship had previously drawn attention for carrying approximately 60 containerized missile launch cells, along with sensor packages and close-in defensive weapons systems. Within the space of just a few days, this commercial cargo vessel had been reconfigured. First into what analysts described as a floating arsenal ship packed with offensive missile capacity, and then again into what appeared to be a functional drone carrier, complete with an electromagnetic catapult track running along its deck. A cargo ship, a vessel that, in any other context, might have been carrying consumer electronics, automotive parts, or agricultural products, had been transformed into a launch platform for armed autonomous drones using modular catapult components that could be assembled and disassembled on relatively short notice. Defense analysts who reviewed the imagery reached a near-unanimous conclusion. This was not an accidental leak of classified information. The imagery had been allowed to circulate. It was a demonstration, a carefully calibrated signal to international observers of what China's military-industrial complex is now capable of. The message embedded in those satellite images was direct and unmistakable. China's vast commercial maritime fleet, which numbers in the thousands of vessels, can be rapidly converted into surface combatants and advanced drone launch platforms with relatively minimal lead time. The modular catapult system observed on the cargo vessel was not a fixed, permanent installation. It consisted of multiple truck-mounted segments that could be linked together to form a scalable launch track. The total effective length of the catapult could be adjusted based on the weight and aerodynamic characteristics of the drone being launched, as well as the available deck space on any given vessel. Think carefully about the implications of that engineering flexibility. If China can mount functional electromagnetic catapults on commercial cargo ships, and do so in a matter of days, then the traditional concept of a naval engagement, organized around identifiable fleet carriers and their destroyer escorts, becomes radically more complicated. A vessel that looked like an ordinary container ship at the start of a crisis could, within days, be a functional drone launch platform capable of deploying one-way attack drones. What military planners sometimes describe as loitering munitions, and what the broader public might recognize by their more commonly used description, kamikaze systems. Unmanned, expendable, launched at scale from ships that until very recently were moving commercial goods through international shipping lanes. The strategic and legal questions this raises are profound. How does a naval commander identify and classify a weapons platform when it is physically indistinguishable from 10,000 other merchant vessels? How does a nation's defense doctrine account for an adversary who can mobilize its entire commercial maritime sector as a dispersed, decentralized weapons delivery network? with very little observable warning. These are not hypothetical academic questions. They are operational problems that military planners in the United States, Japan, Australia, and across the Indo-Pacific are actively grappling with right now. At the foundation of everything the Sichuan represents, and everything the cargo ship experiment demonstrated, is China's drone technology sector. And here, the progress has been remarkable, sustained, and deeply concerning to Western defense establishments. The GJ-11 Sharp Sword deserves particular attention. It is the platform most consistently linked to the Sichuan's intended air wing, and its design philosophy reflects the direction in which Chinese unmanned aviation is heading. The GJ-11 is a flying wing aircraft, no vertical tail surfaces, a blended body that minimizes radar reflectivity, and an internal weapons bay that keeps its ordnance hidden from radar systems during ingress. It is stealthy, not as a secondary characteristic, but as a primary design requirement. The intended operational concept for the GJ-11 is not as a solitary precision strike aircraft. It is designed to operate as part of a coordinated swarm, multiple aircraft operating collaboratively, sharing sensor data, dividing tasks, and overwhelming adversary air defense systems through distributed simultaneous attack from multiple directions and altitudes. The GJ-21 rounds out the picture. This newer design was developed specifically with catapult-equipped ships in mind, optimized for the operational profile of a vessel like the Sichuan, operating at significant distances from contested coastlines, launching drones that can conduct intelligence, surveillance, and reconnaissance missions, provide electronic warfare support, conduct precision strikes against defended targets, and return for recovery and rearming aboard the ship. As one naval technology expert observed, with electromagnetic catapult support, the Type 076 could handle significantly heavier unmanned aircraft, platforms capable of carrying the sensor payloads and weapons loads associated with intelligence gathering, strike coordination, and electronic warfare. This gives a Chinese amphibious assault group something it has never previously possessed: its own organic aviation layer, independent of carrier battle group support. That independence is the key insight. In the traditional architecture of naval amphibious warfare, a landing force was profoundly dependent on carrier-based aviation for air cover, suppression of enemy air defenses, and close air support during the actual beach landing. The carrier had to be positioned nearby, and significant portions of its air wing had to be dedicated to protecting the landing force rather than conducting other missions. The Sichuan eliminates that dependency. A Chinese amphibious task force centered on a Type 076 can generate its own reconnaissance coverage, its own electronic warfare capability, its own air defense suppression, and its own precision strike missions, without any aircraft carrier anywhere in the vicinity. The amphibious force becomes self-sufficient in a way that no previous amphibious force in history has been. For the United States, which has organized its entire Pacific strategic posture around the assumption that carrier battle groups provide the decisive edge in any contested maritime environment, this represents a fundamental challenge that does not have an easy or quick answer. No honest examination of the Sichuan's strategic significance can avoid the Taiwan question. The Taiwan Strait is the geographic and political context within which this ship's design logic becomes most precisely focused and most concerning. Taiwan has spent decades and enormous financial resources building a layered defense architecture specifically designed to make a Chinese amphibious assault across the strait as costly and difficult as possible. That architecture includes anti-ship missile batteries positioned along the western coastline, fighter aircraft capable of striking naval formations in the strait, coastal artillery, naval mines, and an increasingly sophisticated drone fleet of Taiwan's own. The fundamental assumption underlying this entire defensive posture is that any Chinese amphibious assault force would be highly exposed and vulnerable during the crossing of the Taiwan Strait. That the transit distance would give Taiwanese defenders time to identify, track, and strike Chinese landing craft and amphibious ships before they could reach Taiwanese beaches. The Sichuan directly undermines that assumption. Operationally, military analysts assessing the Type 076's likely employment pattern suggest that the ship would remain positioned 150 to 300 kilometers offshore, well beyond the effective range of many Taiwanese coastal defense systems. From that standoff distance, the Sichuan's drone air wing would begin a systematic, methodical campaign to degrade Taiwan's defensive capabilities before a single landing craft was committed to the strait. Radar sites that provide early warning and targeting data for missile batteries, attacked and destroyed. Mobile missile launcher units that represent Taiwan's most survivable offensive capability, hunted by persistent drone reconnaissance and eliminated. Air defense networks that protect the island from air attack, jammed, suppressed, and degraded. Communications nodes and command and control infrastructure targeted for disruption. Only after this preparatory drone campaign had sufficiently degraded Taiwan's ability to detect, track, and engage Chinese forces would the amphibious landing craft move toward the beaches. In military terminology, this is called shaping the battlefield. What the Sichuan provides is the ability to shape the battlefield from a survivable mobile platform that itself presents a difficult targeting problem for Taiwanese defenders, because it is operating from beyond the reach of many of Taiwan's most capable weapon systems.